Your ship just jumped to 10 times light speed. Do your headlights still light the path? Here's the quick truth in plain words. Faster than light travel rewires cause and effect for someone somewhere. FTL means moving through vacuum faster than light moves. That alone sounds simple, yet the stakes are huge. If causality slips, paradoxes follow and physics feels untrustworthy. Relativity draws a speed wall at light within every local frame. Push past it, and different observers can disagree about time order. Some will watch you arrive before you depart. That isn't science fiction drama. It is the math of space-time intervals. World lines tilt, light cones flip, and signals run backward. The picture is weird, but the logic is crisp. Space and time rotate together, like angles on a clock. FTL slices that clock at a forbidden angle across events, so the immediate takeaway is simple. The universe defends causality, not just a speed limit. Could exotic geometry sneak around the wall like a shortcut? Maybe with warp bubbles or wormholes under brutal conditions. These ideas change space itself instead of pushing harder. They move the road, not the car, which matters. We'll stay concrete, with clear numbers and clean examples. If FTL were possible, everyday life would look different. Navigation, communication, even what counts as now, would shift. Cities might speak across centuries by accident during lunch. Net result, FTL touches everything from starflight to memory. Stand on a dark plane under a cold sky. A thin beam from a distant pulsar sweeps past. Spacetime, in plain words, is a four-dimensional stage for events. Its speed limit is the statement that light marks possible influence. This matters because your future depends on reliable cause and effect. Here is how relativity builds that reliability, using simple geometry. Light defines a cone from any event, separating possible from impossible. Inside the cone, influence can flow forward consistently across frames. Outside the cone, influence would require faster-than-light signaling. Change frames by moving fast and tilt that cone in diagrams. The shape stays the same, yet different slices cut different orders. Two events might swap order for you, but not for me. The rule holds because the light cone never tilts past itself. That geometry preserves agreement about what can still influence what. Example in real terms, imagine two fireworks 10 light seconds apart. One pops at 0 seconds, the other at 5 seconds. An observer rushing sideways might disagree which popped first. None can disagree that neither firework triggers the other instantly. One sentence recap, light's cone protects causality by bounding influence. Now picture trying to overtake a flash of light. FTL in this conversation means world lines that cross light's boundary. Stakes jump because such crossings let timelines rethread in another frame. Here is the working mechanism in clean steps and plain action. You send a superluminal ping to a friend in motion. Their moving frame slices spacetime at a steeper angle than yours. That angle makes your ping look like it traveled backward. Your friend answers quickly, also using a superluminal signal. In your frame, the reply can arrive before your original message. You have a time loop created with two ordinary decisions. That loop enables a paradox, like warning yourself about a mistake. The loop can be tightened with faster signals or geometry. Push it hard enough and you get a closed time-like curve. That is a path through spacetime that returns to its start. Real example with numbers, consider 10 times light speed pings. With a relative velocity of half light speed, loops appear. The math sits in Lorentz transforms, not secret wizardry. Bottom line, bare FTL signaling shreds any universal before and after. A sleek craft drifts beside a shimmering bubble of starlight. A warp bubble, in short, is curved space that carries a ship. The point is travel without locally breaking the light limit. The trick works by compressing space ahead and expanding space behind. Locally, the ship sits still, floating in nearly flat space. Globally, the bubble and ship ride a moving patch of geometry. Space itself flows around the craft like a treaded walkway. The calculations say the bubble's rim carries superluminal motion. Observers outside watch the bubble outrun any light pulse. Observers inside never feel acceleration, only tidal gradients at edges. Wormholes chase the same prize through a different door. They stitch two distant mouths together with a very short throat. Step through the throat and you emerge light years away instantly. That is a shortcut in geometry, not speed through normal space. Concrete picture, link Earth to Proxima with a stable wormhole. Crossings take seconds while the stars still sit 4 light years apart. That convenience hides brutal requirements we will face shortly. So the picture is, geometry can cheat distance without local speeding. Hold a diamond on velvet under surgical lights and breathe. Exotic energy, in plain words, means negative energy density for space. It matters because warp bubbles and wormholes need it to stabilize. Without it, rims collapse, throats pinch, and shortcuts slam shut. Here is how the requirements pile up when you run numbers. Early warp metrics demanded energy like the mass of Jupiter. Later designs trimmed totals but pushed stress into razor-thin rims. Quantum inequalities then limit how much negativity can last. They declare that deep deficits must be short, tiny, and compensated. Casimir setups produce negative energy, but only in fragile gaps. Those gaps are micrometers wide, across polished plates at cryogenic temperatures. No known process scales that trick to starship dimensions today. Example with a round number, a 1-meter bubble needs absurd energy. Some estimates reach between 10 to the 44 and 10 to the 46 joules. That rivals total human output across thousands of years of industry. Data from quantum field theory pushes in the same direction. The stresses also threaten to fry passengers with tidal gradients. Net result, the energy bookkeeping crushes naive warp engineering right now. Stars stream past as a vessel knifes through thin interstellar gas. Visual consequences arrive first before any paradox bites your calendar. FTL, if experienced, would twist color, glare, and radiation brutally. Here is the play-by-play that pilots would actually notice quickly. Ahead, starlight blueshifts to X-rays, concentrated into a bright spot. Behind, the sky dims, stretching to longer infrared and radio. Even dust becomes dangerous because relative energy climbs with speed. A single grain can carry kinetic energy like artillery. Hydrogen atoms, common in space, smack shields as high-energy protons. At 10 times light speed, each atom hits with terrifying punch. Their collisions spray secondary radiation throughout the hull and crew. Fields might deflect some ions, but fields can fail under load. Drag also steals energy, unless geometry perfectly carries the craft. Real case numbers help anchor intuition about the environment here. Interstellar gas averages roughly 1 atom per cubic centimeter. Cross a light year and you plow through enormous particle counts. Each interaction dumps heat, damage, and noise into systems. Bottom line, the view gets beautiful and deadly at superluminal pace. Debris hangs in darkness, twisted metal drifting near a frozen clock. Time paradoxes, simply stated, are contradictions inside one consistent history. They matter because reality appears to forbid contradictions with ruthless consistency. The usual mechanism builds a loop that permits inconsistent choices. You stop an event that originally motivated your own intervention. That destroys the reason you traveled, erasing the intervention itself. Physicists sketch 2 broad responses that salvage logic without magic. One response demands global consistency, called the Novikov principle by many. Histories with contradictions never occur, regardless of apparent freedom. The other response blocks the loops with unstable physics. Hawking suggested vacuum noise amplifies, sealing off closed time-like curves. Wormhole mouths might flood with radiation, torching the tunnel immediately. Warp bubble rims might spawn horizons that trap outbound information. Example scenario, you send a message that prevents a disaster. New conditions remove your motive, collapsing the loop on replay. Some analyses allow self-consistent loops that always resolve harmlessly. Others predict catastrophic instability that destroys the time machine. What to remember, causality fights back with consistency or breakdown. There's a milky river of stars arcing over a black desert. Suppose the universe grants a tiny loophole without full paradoxes. FTL could exist in a preferred cosmic frame, defined by expansion. That frame would pick a universal order, saving cause and effect. Local observers would still see weird timing, but never contradictions. The mechanism would cap signaling in other frames, enforcing one clock. Geometry could also allow near FTL corridors that dodge energetic drag. Those corridors might thread low-density voids, mapped by long surveys. A civilization using them would plan routes like ancient mariners. Fuel depots, staging stations, and windows would set launch calendars. The transformation on society would arrive shockingly fast, yet structured. Proxima becomes a weekend trip, not a career-length expedition. Remote telescopes become field stations, serviced by technicians regularly. Trade shifts from bits to atoms, moving medicines and machines. Real number, 1 million stars fall within 1,000 light-years. A network spanning that bubble could hold trillions of lives. The pace of discovery would smash today's timescales to pieces. Bottom line, even constrained FTL rewrites maps, markets, and meaning. A cockpit floats in blue haze, instruments humming with patient confidence. The core idea from the hook still stands and matters. The speed wall protects causality first, not driver pride or engine. We explored why cones guard influence and how frames rearrange time. We checked warp bubbles and wormholes, then priced their brutal energy. We saw skies turn lethal and paradoxes answer with claws. If a narrow loophole exists, it likely carries strict rules. The dream of starflight survives, but the path is narrow. Engineers can still chase better sublight drives with clever staging. Beamed sails, nuclear pulse craft, and fusion cycles stay compelling. None break causality, and all could reach nearby stars. Call back to our opening question about headlights at 10C. They would glare blue, then vanish behind a crushing radiation fog. Calm ask, if this tour helped, consider subscribing for more. I post deep dives on space, time, and technology regularly. One new insight each week, delivered with clean numbers and pictures. Thanks for flying along through geometry's hard boundaries and possibilities. Final takeaway, respect the limit while still aiming for the stars.